प्लीज और पार्टिसिपेंट प्लीज माइक बंद कीजिए आपके। और पार्टिसिपेंट माइक बंद कीजिए। 36 रोल नंबर 35। रोल नंबर 35। बायोडाटा किसके पास है रोल नंबर?
Hello, Gaurav sir.
यस।
43 is going to read biodata
ओके
because
43
he
ना?
has some issue. 43.
नोट ऑफ थैंक्स।
Out of thanks is now his roll number 36 is there.
ओके वेट है मैम 5 मिनट्स। सर ज्वाइन हो जाएंगे अभी 5 मिनट्स।
33, sir ji, you are ready now? 33 sir. Sorry, 43.
Yes, ma'am.
43, I am ready
Yes,
now. 43, I am ready now.
Just wait for 5 minutes. Okay.
32 present, sir.
Okay.
Sir, roll number 13 present, sir.
Roll number 32 present.
13. I'm talking about 13. Tera.
रोल नंबर 43।
Roll number 13 present,
Yes, sir. 43, sir.
सर रेडी कर दीजिए बायोडाटा। सर ज्वाइन हो चुके हैं।
Okay. Good afternoon, everybody present. Sir, am I audible?
यस राइट सर।
Good afternoon, everybody present. It's really a great pleasure for me to be a part of the today's program of UGC Malviya Mission Teachers Training Center, organized by Dr. Babasaheb Ambedkar, Marthawada University, Sambhajinagar, Maharashtra. I am Dr. Lakshman Chandra Pal, Assistant Professor in the Department of Geography, Vidhan Chandra College, Rizra, Hooghly. I am now going to start to introduce Professor Prakash Raut as the eminent resource person of the afternoon session. Dr. Prakash Raut, MSc in Zoology, PhD, and specialized in environmental taxonomy, ecology, and biodiversity, is the Chief Executive Officer of SUK Research and Development Foundation and ex-professor and head of the Department of Environmental Science, Shivaji University, Kolhapur, India. He was former IC Dean of Interdisciplinary Studies, former IC Head, Department of Geography and Zoology of Shivaji University, Kolhapur. Dr. Raut is also working and worked on various bodies, committees, and establishments such as Senate, Management Council, BOS, BOE, Coordinator, Chief Rector, and so on. He is also a member of various national and international organizations like PNHS, IBCN, WWF, and various other research societies. Dr. Raut has 43 years of teaching experiences. During this time, 18 students have completed their PhD, 6 students MPhil, and 22 students completed their MTech degree under his supervision. He has completed many research projects such as MO, EFTC, DAE, BRNS, BARC, and UGC with a funding of around rupees 2.22 crore with themes on GIS study of wildlife sanctuary, flora and fauna, demography and geomedical study of groundwater. Professor Raut has published 98 research papers in various national and international journals and attended 86 national and international conferences, seminars, and workshops in India and abroad to present paper and deliver lecture. He has received gold medal and FAEB fellowship of Academy of Environmental Biology, Lucknow. He has honored by University Best Teacher Award 2017 by Shivaji University in 2017. He also has been facilitated by Bosundara Gaurav Award in Kirloskar Bosundara Festival in 2018. We must be enriched with the lectures of such eminent person. Now, I request Dr. Raut to start the lecture. Thank you, sir.
Good afternoon to all. I think Dr. Poonam Singh, roll number 65.
कोटि कोटि प्रणाम करते हैं।
Poonam Singh, roll number 65.
कि हम सब आपको
Mute yourself.
ऐसे व्यक्तित्व के धनी हमारे मार्गदर्शक माननीय संतोष सर के लिए कुछ पंक्तियां कहना चाहूंगा कि हम तो कोरे कागज थे किनारा आपने दिखाया
Mic
कि
is
हम तो
on.
कोरे
Can you
65,
hear me?
65. Please unmute.
Okay.
65.
I'm audible?
Yes, sir, you are audible now.
Yes, sir. Yes, sir. Yes, sir.
Okay. Should I start?
Yes, yes.
Okay.
Please continue, sir.
So, good afternoon to all of you. Before I start, I must thank Dr. Baba Sahib Ambedkar Marathwada University, Sambhajinagar, for calling me here for the UGC Malviya Mission Teachers Training Center for this refresher course in disaster management. So friends, I have taken the first topic of my lecture is the disaster management. In special, I have taken flood disaster management because at many places, this flood situations they are happening, and because of this flood, lot much of what we can say, the establishments they get disturbed, the people they will get displaced from the place, and because of that, this situation it is happening at many places, and because of that, this particular topic I have chosen. But before starting with this particular flood topic, just I wanted to brush up your knowledge because this particular course it has started on 3rd and now it is I think 7th. So many people they must have talked about what exactly is disaster, but to give a brief introduction of this particular topic, I must tell you what exactly this disaster is. So anytime, even if you come out of your house and anything happens, we call it as a disaster. So what we can say, the disaster is a sudden calamitous event bringing great damage, loss, destruction, and devastation to life and property. Means, as I said, if you come out of your house and some two-wheeler it comes and dashes you, that particular thing, it is nothing but an accident. But what we can call it as, it is a sort of a man-made disaster which has happened with you. And because of that, we usually call it as, it is a sudden calamitous event bringing great damage, loss, destruction, and devastation to life and property. It can be also termed as a serious disruption of functioning of society. Means many things. For example, I can give you at this particular point of time, when there is a flood, the water distribution motors, they go underwater, and the entire system of distribution of the water, it gets disturbed. There will be no water in the city or a village. So what we can say, disruption of the functioning of society causing widespread human, material or environmental losses which exceeds the ability of the affected society to cope using its own resources. Means you will start finding the other things which will be required to fulfill your what we can say, the conditions. Okay. So thus, in simple terms, we can define disaster as hazard causing heavy losses to life, property, and livelihood is considered as the disaster. For example, a flood causing loss of lives as well as property. Okay, a cyclone killing 10,000 lives, it can be also considered as a disaster. A crop loss of 1 crore because of what we can say, a drought or a flood, that can be also considered as a disaster. It can be also considered as a disaster. Now, there are different types of these disasters. There are mainly two types of disasters, as natural and the man-made disaster. The natural disaster is one, it affects the, it is the effect of a natural hazard that affects the environment and leads to financial, environmental, and or human losses. Okay. So one which has been caused by the natural events, natural events. lecture मध्ये it is what we can say, the disaster which will be caused by the natural phenomena, it is considered as a natural disaster. It is considered as a natural disaster. For example, flood, volcanic eruptions, earthquake, or landslides, etc. We can consider it as the natural disaster. Whereas the other one is the man-made disasters. It can be a threat having an element of human intent, negligence, or error, or involving a failure of a man-made system. Okay, for example, there will be a fire, war, pollution, food poisoning, nuclear power plant, etc. Okay, so all these, they are considered as the man-made disasters. So basically, we have these two types as natural disasters and the man-made disasters. Okay, so based on the devastation, this further they are classified into major and the minor disaster. For example, major natural disaster, it consists flood, like cyclone, drought, earthquake, etc. Whereas the minor disasters, they are the cold waves, thunderstorms, heat waves, mud or the landslides, storms, etc. They are considered as the minor natural disasters. Whereas the major man-made disasters, there will be setting of a fire, means there will be fire to the forest. Then there will be an epidemic. This epidemic, it may be because of the spread of the infections to the people. Epidemic will be there. Deforestation, the cutting of the trees. Then the pollution, the release of the sewage or the effluents into the water bodies, it leads to the pollution of water, release of the air pollutants or the gases into the what we can say air, it leads to the air pollution, and adding more solutions or chemicals into the soil leads to the soil pollution, as well as the wars. They will be also considered as the major man-made disaster, major man-made disasters. Then there are minor man-made disasters. For example, road and train accidents. Road or train accidents. There can be a minor, there can be also major accidents also, as well as daily there will be minor accidents, they are also possible. Okay, then there are many riots will be there amongst the society, so that will be also considered as a disaster. Food poisoning, it is also considered as the minor man-made disaster, industrial disasters or the crisis, as well as the environmental pollution at a local level, we can consider also as a man-made disaster. It can be also considered as a man-made disaster. Now further, as we are now going to see what exactly this flood disaster it is, just I am from Shivaji University, and the Kolhapur city, it has been happened with this flood situation many times. There was a flood situation in the year 1989, then 85, 1985, 2005, then 2019, 2021, and 2024. So all these years, these floods, they are coming. So by taking example of this Kolhapur city, we can try to understand that how this flood situation disaster, it can come. What are the reasons for this, that we can also see. At the same time, we are also trying to see what exactly it has happened for the flood situation in Kerala also. So just as a title side, I have kept this because you can see the situation. This, what you can see here in the middle is the national highway NH47, which is leading from Pune to Bangalore. It has been closed for at least 15 days. So the situation was very bad. The entire thing, the city was not getting water during this 15 days because all the pumps, they were underwater. Okay, and because of that, this situation which happens because of flood, it is a very serious situation, and it has been considered as the flood disaster. It has been considered as the flood disaster. So we have to understand that how this flood disaster can be managed. How this flood disaster, it can be managed. Now, before going for this, you should know what is a flood. Now, excess of water, when it comes, whether it will be because of the raining or whether it will be because of some leakage or something, the flood situation, it happens. So what we can say, an overflowing of water onto land that is normally dry. So regularly there will be no water, but because of the excess water will be coming by the rain or by some other artificial situation happened, and the water, it will come on the normally dry area, and that gets flooded. The situation, we are calling it as the flood situation. So an overflowing of water onto land that is normally dry is considered as a flood. The flood hazard is compounded by the problems of sediment deposition, drainage congestion, and synchronization of river floods with sea tides in the coastal plains. So we can also consider that during the tides, high tides, usually happens that the coastal plains, they get flooded. Coastal plains, they flooded, and there also can be possibility sometimes the flood because of this tide, it comes or it rises very much and it comes on the dry land. Okay, so what we can say, the floods are water related disaster. You can see some pictures where you can see that the water, it has come in the residential area. Water, it has come into the residential area, and this water, it is due to over what we can say within a short period of time, excess of raining, it has happened. Excess of raining, it has happened. What are the reasons that we can see further? What are the reasons we can see further? So what are the causes? Okay, so flooding conditions may occur due to, first we can say river in spate. River in spate. So what we can say, the spate means the condition of river in a natural state. It will not remain because of lot many reasons. The river, it becomes smaller. The depth of the river, it will get reduced because of the silting. So all these conditions. So there we can say river in spate. Then snow melt, excess of the melting of snow. So in India, we can say towards the north side, because of the melting of the snow during the summer season, the rivers, For example, Ganga, Yamuna, they get flooded. Okay, then there will be storms, surges. Due to storm, there will be heavy rain, and this heavy rain also it leads to the flooding. Short, intense storm causing flash floods. Now, this condition of these flash floods within a very short period of time, we can say within 1 hour or half an hour or 2 hours or 3 hours, what happens that a very, I can say, heavy rains or the showers they come, and within a short period of time there will be a flood, and that flood it is considered as a flash flood. Tidal and backwater effects. The tides many a times it will be very high, and that time there will be a tidal or backwater effect. It can be also seen. Okay, now flooding in rivers, it is been mainly caused by the first thing we can say inadequate capacity within the banks of rivers to contain high flow. Now, if you see the condition of rivers everywhere, you will find that the river plane, it is getting reduced. The depth of the river, it is also getting reduced. And because of that, there will be capacity of river to carry water. It gets reduced. Inadequate capacity within the banks of rivers to contain high flow of water. So there is no place to flow this excess of water, and that leads to the flood. The second thing is river bank erosion and silting of river beds. River bank erosion and silting of the river beds. So this silting, it is because of the erosion of the soil, the local soil or the soil which is coming from the mountains, because of mining. There are many reasons for the erosion. The deforestation of the forest, as the trees they are not there, and the soil it comes into the river bank, river plains, and the depth of the river it gets reduced. The river beds they will get filled. The third reason is landslides leading to obstruction of flow and change in the river course. It can happen at many places. There will be possibility of landslides. Nowadays, everywhere, I can say everywhere, this machines, particularly JCBs, they are used for this mountains, to make this mountain land to the agricultural land, and lot much of the vibrations they are there, and these vibrations they are leading to the obstruction of the, or what we can say, the landslides, and these landslides in the river beds makes the obstructions to the flow and change in the river course it happens. Okay, now this particular type of thing, change in the river course, it happens usually in the desert area also. For example, Jaipur and Bikaner and all these areas, it is a desert area, and there this river course it will get changed. The next is synchronization of flood in the main tributary rivers. See, if this tributary, if the heavy rains, if they are there everywhere in the area, the small tributaries will be also flooded, as well as the large river also it will be flooded. So whatever water it is there in the small tributaries cannot enter into the main river. And ultimately, because of that, what happens? The spreading of water it takes place, and this leads to the flood. The next is flow retardation due to tidal and backwater effects. Now, this usually happens like areas like coastal areas like Mumbai or Calcutta or Madras. When there is a high tide, the sewage water and the water, storm water, that is rainwater, it cannot enter into the sea. And ultimately, because of this, the flood situation, it happens. Many times this flood situation may remain in the cities, coastal cities, for 1 day, 2 day, it may remain. And as well as the next thing is poor natural drainage. The natural drainage, if it is not there, there is possibility that lagging of the water, and there can be possibility that the flood situation may happen. The drainage of this water, it may not take place. As well as the cyclones and heavy rainfalls. cyclones and heavy rainfalls, they are also been responsible for this floods into the river, river. Okay. Now, types of floods, mainly three types of floods they are there. The first one is snow melt floods. Now, usually in the northern region at higher altitudes, on the mountains like Himalayas, ranges of Himalayas, the snow during the summer season, as there is rising temperature, snow will melt, and this snow, it leads to the flow of water, and this flow of water through the tributaries, it will come into the main river, and all these rivers in the northern area of India, they get flooded. Okay. So the snow melt floods can be very large floods. There is a possibility that this floods there, and because of this global warming and rise in temperature, actually there is 1.5 degrees centigrade rise in temperature, it is there, and this rise in temperature is leading to the snow melt and is leading ultimately to the flood. The second one is storm surge floods. Floods in coastal areas and in river estuaries are usually due to storm surges, which result from the sea being driven onto the land by meteorological forces. Usually, the east coast of India is particularly prone to storm surges. You will find that on the west coast of India, the storms, they are very few. Even though the storms, they are there, usually they go inside the sea. But on the east coast, usually storms, they come on the coastal areas, and lot of what we can say, the houses, trees, they will be affected by the storm surges. Now, this particular flood will be there for a short period of time, but it will be a very heavy flood. It will be a heavy flood. And the third one is the flash floods. Third is the flash floods. The floods of short duration with a relatively high peak discharge. Floods of short duration with a relatively high peak discharge. So during a very short period of time, there will be heavy rain. There will be heavy rain, and they arise from local precipitation of extremely high intensity. For example, typical of thunderstorms. These thunderstorms, they lead to the flash floods. That will be there for a very short period of time, and because of that, it has been called as a flash flood. It will remain for 1 hour, 2 hours, and once the rain stops or the storm stops, actually all the water through drainage, it will lead to the rivers. Okay, that is what we can call it as the flash floods. So there are three different types of the floods: snow flood, snow melt floods, storm surge floods, and flash floods. Now, what is the scenario throughout the world? What is the scenario throughout the world? The floods are worldwide a major hazard. Means you will not say that there will be floods in India only, but the floods, they are there throughout the world. The floods are there throughout the world. Okay, so we can consider these floods as a major hazard. The death of the people, average death of people, is around 7,000 people per year. They die because of the deaths will be there because of the flood. The World Meteorological Organization, WMO, of all natural hazard has said the flood has greatest damage potential. Okay. Over 1/3 of total damages that will be caused by the floods. So if there is this flood in a particular area, what happens? All the places there, they will be washed out. And because of that, damages which will be caused by the flood, they are very much affect the greatest number of people. Okay? So all the people, mostly you can say 2/3 of the people, they will get affected by the flood of that particular area, flood prone area. And And this impact worldwide, it has been increased rapidly. Roll number 24. Roll number 24. Please mute your mic. Now, the number of flood disaster by countries from 1974. You can see this world map. And in this world, roll number 24. Roll number 24. Chetan Gaikwad. Okay, I think his speaker is not on. If anybody is having his mobile number, you can just call him and tell him. Okay, so if you see this plus disaster number, you can see the colors. This yellow color, it represents that the floods in this particular countries is from 0 to 15. And orange is 16 to 60, and above 60 is red. Our country, it has been there. It's more than 60 floods. They will be there in our country. In our country, more than 60 floods they are there. More than 60 floods they are there. So we are having a more flood-prone area. Now this is again our map of our country, and you'll find that these are the blue flood-prone areas in our country. Flood-prone in our country. So you can see the northeast is there, and then West Bengal it is there. So different areas you'll find. Rule number 24. Rule number 24. Chetan Gaikwad. Chetan Gaikwad. Okay, frequency of flood worldwide. Now, if you see this scenario, if you see this map, you'll find this graph, you'll find that from the year 1900, the frequency of the floods, if you see, it was less. But as you go further and further, with the development of the society, you'll find that the situations of this flood worldwide, they are increasing. Worldwide, they are increasing. Now, the reasons, they can be different. There are many reasons. There are many obstacles. They have been artificially created in the areas because of the situations like global warming, climate change, the what we can say, the frequency of the rain, it is changing. So usually what happens, the rainy season will be there for 4 months, but actually what happens in the month of June, there will be no rain, and in July or August, in a very short period of time, the rain, it rains heavily, and there will be a flood. So this type of situations you can find. All these things we can say it is related with the pollution, it is related with the global warming. Okay. Now, what exactly the hydrological response to these floods? Hydrological response to the flood. Now, you can see those who are there studying microbiology or from the life sciences, they will understand this particular type of a graph. It is usually called as a typical growth curve like graph. So this is leading time. This is steady time, or you can call it as a lag time, and this is a recession time. You can see here when there is a flood, usually the flood, it starts with the rain, heavy rains. You can see that here there is a heavy rain, these are the days from a particular area, that is North Fork, Nooksack at Glacier. And these are the dates, and you will find that the situation of this rain, and because of heavy rains, what has happened on this particular date, the flood frequency It has got increased, and slowly as the rain stops, slowly the flood it has recessed. Okay, so that is what we can say a condition hydrological response of the flood, Now to understand this flood, we'll also have to study the geography as well as geology. Now you can see here the stream order and flood response. Okay, stream order and flood response. Now suppose this is the main river. This is a main river, and these are all tributaries. These are all tributaries you can see with this joining to this particular main river. And what you will observe that this is the first order stream from this area. This is the catchment area of this. Here for this, there may be possibility of this catchment area. Again, small tributaries thereof. The streams, they will be there. Drainages, they will be there. So this situation, you can say, is of first order. This is the first order. You'll find that if there is a heavy rain in a particular area, you'll find that this particular time which will be taken for having a flood, it will be very short. The peak you will get of this particular curve will be very fast in this particular area. Now further, if you go, for example, this is the first order stream, this is second order stream, this is third order stream, and this is the fourth order stream. Now what happens with this fourth order stream or this river, you can say river, all this water in this drainage areas of these streams, that will be collected and that will be poured into this river. And because of this, even though the rain from this area it has gone, at some other places the rain will be there. So there will be some reservoir dam. The water from that reservoir or dam, it will be also been released into this river. And because of that, the flood situation, the peak, it will remain for longer period of time in this particular area. Means flood in these areas, it will be remaining for longer period of time. But if you see here, this will remain for very short period of time. But in the main river, you will find that this particular flood, it will be there for the longer period of time. This will be there for the longer period of time. So from this particular picture or figure, you'll understand that what type of river it is, whether it is a first order, second order, third order, fourth order, whether it is the first part of the river or it is the last part of the river where it is meeting the sea. Okay, a part of estuary, that all these things, they will be also been considered for the flood response. Now, the regional climate and the flood response. Now, see if the condition of a particular area, the area is arid, dry area. See, this is a river, these are the tributaries or the streams which are ultimately joining to this river. If you see the rivers in the arid area, usually they are dry. Even during the rainy season, little water it will be there in this rivers in an arid area. Okay, but on a particular day or particular time, what happens? There will be a heavy rain. Heavy rain will be there, and all these streams, they'll get flooded and they will bring water to the main river. This is the main river. To this, the water will be brought. But because as this area is arid, much of the water will be absorbed. Much of the water, the area for carrying this particular water, it is much in this arid area in the river, and ultimately what happens, the water, it will be carried or it will be drained by this river very fast, and the time of this flood situation will be for a very short period of time. You can say the recession of this flood, it will be it will take very short period of time. The same is the case if you consider it for the humid environment. you'll find that already the soil, it is humid. Soil, it is having water contents. And because of this, the absorption of this water by this area, it is very less as compared to this dry area. And because of that, what happens? The water, it will remain on the surface. Water, it will remain on the surface on all the areas, the first order stream, second, third, fourth, everywhere the water, it will not be absorbed and will remain in the, what we can say, the runway of this river, runway of the river. And because of that, the period of this flood, it will remain for the longer period. This response of flood, it will be for the longer period of time. The recession of the flood also, it will take more time in this humid area. Okay, so climate is also very important for the flood. Climate is also very important for the flood. Now, further if you see, the geological substrate is also very important. Geological substrate, it is also very important for the flood. Okay, the response of the flood. For example, the first area, if you consider a shell, this is a shell, hard rock, it is there. Hard rock, it is there. And these are the tributaries in this hard rocks, and this is the main river, or you can say the fourth order stream, that is the river. Now here what happens? The water which will be there in all these streams, it will come down into the river. As it is not been absorbed, it will flow through this river, and ultimately the flood situation, it will remain for a shorter period of time, and the recession will take place within a short period of time. That is what it happens in a shell area, that is the hard rock stone area. It happens in the hard rock stone area. Whereas if you see the same in the sandstone area, where there is a possibility of little absorption of the water, here what will happen, that the rainwater, it will flow through this, but the main flood, it will be remaining for a more time than this shell area in the sandstone area, as well as the recession of this flood, it also take place for a longer period of time as compared to the shell area, Whereas the third area, it is the limestone, where there is a possibility of absorption of water. The water content, it will remain there in this area for a longer period of time. So what happens here? That the water, it will be hold in the area, and because of that, the flood situation, it will remain for a longer period of time, as well as the recession of this flood, it takes longer period of time. So what we can say on the substrate condition, geological substrate condition of the area, if it is shell, the flood, it will remain for a very short period of time. If it is sandstone, again, as compared to shell, the time of flood, it will be more. And if it is limestone, the flood condition in the area, it will remain for a longer period of time. Okay. Now, basin geometry, also it is very important. If the area, the drainage, we can say drainage, if it is circular, the area, if it is circular, what we can say, the flood situation, it will remain for a shorter period of time. Once there is a rain, once there is a storm, immediately whatever water it is there been accumulated in these streams as well as river, it will be taken away. The flow will be faster. In this area. So peak period of flood will be for a shorter period of time, and the recession of the flood also, it will take place for within a very short period of time. Whereas if the drainage or the area, if it is oblong like this, and this is the main river with these tributaries or the streams joining it, what will happen? The period of holding of water, it will be for a longer period of time. The peak flood or the situation will be there for the longer period of time. Okay. Whereas the recession of the flood also, it will be taking place time. The water which will be accumulated in this area, it will not go away from the area. It will take time. So recession of the flood, it will also take time. Whereas in case of this elongated area, the drainage area, these are the streams and the main river here. The flood situation, it will take longer period of time. The water will remain in this area for longer period of time. The drainage of the water, it will not take place, as well as the flood, it will remain in this area for longer period of time. So what we can say, the basin geometry, the drainage basin geometry, it is also very important, and on the basis of that also the flood situation, it will remain. The time of the flood situation, it depends on this. For example, it is circular, the period of flood will be short. If it is oblong, it is more than this circular, and if it is elongated, it is more than the oblong. Okay, so that condition also you'll have to take into consideration based on that particular area. Now, land use and flood response. Land use and the flood response. If it is a forest, the area is forested. Okay, lot much of the agriculture it is there. With the forest, what will happen? This peak of this, it will be for longer period of time. Okay, because the holding capacity of water in this area, it will be more. Okay, so in this river, the water remain for longer period of time in the forested area, whereas only agriculture is there, not much forest is there, only agriculture area is there. As compared to this forested area, the flood situation, it will be for shorter period of time. Flood situation will be there for the shorter period of time, as well as the recession of the flood, it will be also for a little longer as compared to this. Okay, whereas in case of a urbanized area, what happens? The flood situation, the response, the flood situation or the response, it will be for a shorter period of time, as well as recession of this is also very fast, because many a times in an urbanized area, the what we can say, the drainage system, the gutters and all, the storm water management, it has been properly done, and because of that, in urbanized area, the situation of flood, it will be not remaining for more time, but in a particular situation in urbanized area also, sometimes flood remains for more time, but the reasons for that, they may be different at different areas. So land use pattern is also very important in flood response. Land use pattern is also very important in the flood response. Then the third thing, the next thing is floodplain morphology. Now you can see the cross section of these two rivers. The depth of the river, it is very important. Now at the base, you can see of this river basin is silt. The basin of this river, it has been filled by silt. It has been filled by the silt. Now, even though this basin is broader, the depth of this river, it is not that much, because this river, it is the plain, it has been filled by silt, and because of that, the flooding in this particular area, it is very fast. The water from this this plain, flood plain, the river plain or river basin, it come outside very fast. Whereas in the narrow floodplain, the depth of the water, it is more. The siltation will be there at the base of the water body or the river basin, and because of that, here there is a possibility to carry out more amount of water from this narrow floodplains. And because of that, when the narrow floodplains are there, usually the flood, it will not be remaining for a longer period of time, because the drainage of water is faster. Okay, so floodplain morphology, it is also very important. Floodplain morphology is also very important when you think of the flood disaster. Now, how we can manage this floods? How this flood disaster, it can be managed? Now here at this particular point, you can say there is a disaster. Many times you know that your area is flood prone area. For example, now Kolhapur city is considered as flood prone area. Sangli city is considered as flood prone area. Okay, and because of that, nowadays, if you see the management process, here the preparedness for the flood. Now, before rainy season starts, that is in the month of May, the preparedness always it has been done in this district to fight with the flood. Okay, so if there is disasters of flood, there is a response. If there is a disaster of flood, there is a response. So response will be there. That is the areas they get flooded. If the people they are staying there, if the cattle they are there, or other this animals they are there, they have to be evacuated. They have to be. So that becomes the response, and to that there will be a recovery. From this you can recover the area, and then you can go for the mitigation of this particular response or this disaster which has been caused by the flood. Okay, so this is the risk reduction. Further, there will be risk reduction. How we can do this risk reduction? You can move the population, you can move the cattle at the different areas where the flood is not there, or at the higher altitudes. Okay, then the prevention. This is for the previous this thing, prevention and the preparedness. This is for the next particular flood. Okay, you can go for preparedness as well as for the prevention. Means the instructions they'll be given to the people that in the flood prone areas, the houses they will not be built and all. So there are some regions they have made that we can see further. So this is in general, we can say any disaster is there, this particular cycle, it will be maintained by the government to take over or to manage this particular disaster. Okay, now if you consider our country, in our country, the flood prone area is 14 million hectares. 14 million hectares, and out of that 21.9% is there in UP, that is Uttar Pradesh. 12.71 it is there in Bihar, 9.40 in Assam, 7.91 in West Bengal, and 4.18 in Orissa. And then these are the other regions of India, that is 43.9 in other states. Means these are the states. Maximum Uttar Pradesh is getting these floods. Uttar Pradesh is getting this flood comparatively compared to other states. Okay, so this is the flood areas, prone areas in our country. This is the flood prone areas in our country. Just a minute. Okay. Now, what are the causes for this? In our country, what are the causes of this particular vulnerability of these floods in our country? Now, the first thing here for the floods is
budget district.
Sure. So we have created a single presentation only.
You can see the presentation. Hello, can you hear me? Am I audible?
Yes,
Am I
sir. Yes,
audible?
sir.
Yes, sir.
Yes, sir.
Okay. Somebody said something. That's fine. See, the first thing is indiscriminate encroachment. Here you can see these are some pictures. These are some pictures, and all these buildings you can see they are in the areas of river, the river basins. You can see these are the buildings in river basin. So indiscriminate encroachment, it is the first cause. And definitely when there is a flood, these buildings, they are going to go under water. Increasing economic and developmental activities in the floodplains. So there are a lot many industries, then the houses, schools, universities, they have been developed. Even markets, they have been developed in the flood prone areas or the flood plains. Okay, so they are definitely going to become a vulnerable regions for the flood. There will be lack of regulations. You cannot say lack of regulation. Regulations are there, but these regulations, they are not being followed. They are not being followed. There is always a blue zone and red zone. Okay, blue line and red line when there is a river passes through a city. In the urban areas, the regulations are there, but these regulations, they are not being followed properly. So we can say lack of regulation, inadequate draining system. So this happens, the drainage system, the storm water, it should be taken to the river. That system, it is not being developed in many areas. And because of that, what usually happens is inadequate drainage system, it leads to the vulnerability towards the flood. Inadequate maintenance, all this desiltation, it is very important. The streams, the storm water, the pipes, they should be cleaned properly, regularly. So inadequate maintenance, that also leads to vulnerability to the flood, and lack of disaster preparedness. Nowadays, that particular thing, it has come, but preparedness, it is not much yet. Whenever there is a flood, people, they start doing these activities. Preparedness, it is not there. But little where usually the floods, they are coming, that areas, this preparedness, the district collectorate, they are doing this preparedness nowadays. Okay. Now, what is the approach for this flood management? You can see some figures, pictures down. The first thing is floods cannot be absolutely controlled. The first thing what we can say, the floods cannot be absolutely, because it is not in our hand. To control these floods, it is not in our hand. Okay, because if there is a heavy rains, if there is no way to go from the river, the water definitely will come in areas wherever it is possible. Okay, low-lying areas, they will get flooded. Okay, so very, what we can say, minimum thing, it is there in our hand to reduce this flood. Okay, so they cannot be completely controlled. Floods can only be managed to reduce flood losses. Flood losses, they can be reduced by the preparedness. Before floods, before rainy seasons, you can take some actions so that the losses, it can be reduced. Now, for this, some strategies are also there. The first thing, you can say, modify the flood. The water which is there in one area, you can shift it to the other area by the streams, canals, etc. You can take this flood water from one region to the other. Connecting the rivers, that also it comes under this management strategy. Modify susceptibility to flood damage. Whichever the area, it is susceptible to the flood or the flood damage, it should be modified. So that the people, property, the goods which will be there in the area, they can be saved. Modify the loss burden. That is what you can make the things in a different way so that the losses will be less. Or ultimately, if you are not doing anything, you have to bear the losses. The losses, they have to be bared by you if you are not following the strategies. Now, there are many organizations worldwide to manage the flood. For example, in our India, State Flood Control Department is there. Okay, they take some actions. Central Water Commission, it is on the top, which is also taking some actions by the way of which the flood prone areas, they will be under less losses. Then there is Ganga Flood Control Commission. It is also there, which looks after the flood of the Ganga river. Then there is another board, that is Brahmaputra board, which has also been looking after the management of flood of Brahmaputra river. And Ministry of Home Affairs, MHA, which if there is a flood, to protect people, shift people, that work it will be done by the Home Department. And National Disaster Management, NDM division. They have a better role, or you can say the major role to be played for the flood management. Evacuation of people, cattle, property, all these things, it will be done by this NDRF people or the National Disaster Management Division, NDM division. Okay. Flood management measures. Now, the first thing is structural. Now, in the previous figure, physical works for measures modifying flood to keep floods away from people. In the previous picture, you can see here, see some walls they will be made so that, see the artificial walls they will be made so that the water it will not come in the residential area, but they are not the main, this thing, barricades they will be made. The structural things, even the dams, building up of the dams, it comes under the flood management measures. Okay, you can modify the flood to keep the flood away from the people. Okay, so that they are called as the structural flood management measures, structural flood management measure. Whereas the second one is non-structural measures. Second is non-structural measures, that is the planned activity to modify susceptibility to flood to keep people away from the flood. So now the flood prone areas, they will be evacuated. Even though the flood is not going to come, you have to take action that the flood prone area people, they will be shifted to a protected area. So that is what we are considering it as the non-structural measures which you can take. Okay. Then structural measures, you can see here dams and reservoirs you can make. There are a lot many dams are there. Embankments they'll be made, like there's embankments there. Channel improvements they can be done. River diversions, the river will be diverted so that wherever there is no water, there is no flood, this water, excess of water, it will be diverted. And inter-basin transfer. But all these things, what structural measures we will be following, they are very costly. Very costly, means there is many times lifting of the water, it will be there. And the lifting of the water at many places, it leads to a lot much cost. Okay, and anti-erosion works. This is a proper way, anti-erosion works, because usually what happens if there is a erosion, what happens that the silting of the river beds, it takes place, it leads to faster floods. Now, these are the non-structural measures. The flood forecasting and warning. Okay, nowadays there are a lot many sensors. In the flood prone areas, the sensors they are there. If the water, if it is coming in a particular area, from that area, the water to come in the city area, it takes some particular time. Till that time, the warning it will be given to the people. Okay, so forecasting, IMD, meteorology department, they can forecast that the heavy rains they are going to come. If you are staying in a flood prone area, you can shift. Okay, so forecasting and warning it is given, and now latest technology it has been used here. Floodplain zoning it is there. Here, this is zoning of the floodplains that we'll see further. Flood fighting. So this is fighting, you can say, the shifting of the people from the flood. And all these activities, it comes under the fighting, flood fighting. Then flood proofing. Before this, you have seen the structural and non-structural also. Flood proofing is also there, and flood insurance is also there. The insurance also, it has been given to the people. Flood insurance also it will be given. And now the insurance companies, they are coming with the flood insurance. There there is a damage of your property, furniture, cattles, okay, even the human life, all this is being given by some companies as a flood insurance. Okay, the premium for this, it will be definitely higher, and relief and rehabilitation of the people, cattle from the flood area to the other areas, flood areas to the other areas. Okay, so these are the non-structural measures. Okay, now what is the concept of this floodplain zoning? An important non-structural measure. It is an important non-structural measure. It regulates land use in floodplains to restrict damage by flood. And involves demarcation of zones in floodplains compatible with flood risk involved. Okay, so this is what is the concept, and they have made these 3 regulation zones. As the first one is priority 1, where activity limited to water levels corresponding to 100 years flood frequency and drainage congestion of 50 years rainfall. Here you can see this is the first one, which we can call it as a warning zone or the priority 1 zone. In 50 years, in 100 years, if the flood does come only once, you can come under the priority 1. Okay, so priority 2 is activity limited to the level corresponding to 25 years flood frequency. Means once the flood has come in 25, drainage congestion of 10 years rainfall. Drainage congestion is of 10 years rainfall. And the third one is less economic and community activity in areas vulnerable to frequent floods. This is called as a blue line area. The blue line area where always the flood comes. Whenever there is a rainy season, always the flood comes in this area. Okay, so these are flood prone areas only, and it comes under the third priority. Okay, so here in zoning, this is a warning zone where the residential activities, shopping complexes, markets, universities, colleges, they are there. Restrictive areas, there very few activities they'll be done. Okay, and the third one is the prohibitive. Well, this is actually the channel of the river. This you can say it is a blue line only, whereas this one is a red line and this is a green line. Okay, so blue, red, and green. Okay, so these are the 3 priority areas considered as warning, restrictive, and prohibitive area. Okay, so here this is a picture, a diagram we can have. This is a first area, priority 1 area, where factories they can be there, powerhouses will be there, universities, schools, etc. will be there. In the second area, you can have few activities like government offices, few residential area. You can see this is a residential area towards the outer side. Whereas in the third area, the blue line, there will be only gardens. There will be only gardens. Here you can say the flood will be there in 100 years once. Here in this 25 years, and this is an area which is marked black. Regularly the flood it comes, and because of that, this area no constructions will be avoided. This area, it is considered as a blue line. This is considered as a blue line. Nowadays, what is actually happening in this blue line area, all the what we can say the residential area, it has been covered, and this residential areas, they are becoming barricades for the flow of river water or the flood water, and ultimately the flood it has been coming. Okay, the flood forecast beginning in India, it has begun with the Central Water Commission in the year 1958 for river Yamuna, and this particular forecasting station has been there on Delhi Bridge. Okay, the steps which have been involved in this is the data collection, then data transmission, data analysis, and forecast and dissemination of the forecast. Everything it will be done by these centers like this. Okay, so all the data will be collected, and the information will be analyzed and will be distributed to the flood prone areas. Okay, then data collection, hydrological. What is the river water level? For example, river, it is flowing in a particular area. In previous 10 kilometers, what is the level of water? And how much this level it will be acquired by the river in a city area. River discharge, how much it is, that data it will be considered as river water level and river discharge data. Hydrological data, it will be rainfall. Other precipitation, that is because of snow, hails, etc., storms, etc. So all this data it will be collected. This is called as a data collection, and this data it will be transmitted. Now satellite, it is what we can say machine what we have got now, by the way of which immediately the data, real-time data, now we can call it as a real-time data, it can be transmitted so that the preventive actions they can be taken very fast. The second is wireless, telephone, fax, telegram, telex. But for all this, the electricity is required. And if all these things they are there in the flood-prone areas or in the flood, all these things they will not be useful for the transmission of data during the flood situation. And this analysis of this data will be there, and that will be useful for the forecasting. There are a lot many models and formulations, formulas, etc. For example, there will be correlation formula which has been used by the statisticians. Mathematical models are there. But all these correlation mathematical models, which will be prepared by the scientists, IMD and all, they usually fail because the nature, the rain, where it will fall, at what rate it will fall, nobody knows. So all data analysis, even though we are doing, many times it will not be useful. Okay. So dissemination of this flood forecasting, it will be done this way. The forecast, firstly, it will be given to the civil authority, other agencies. Civil authority, it will give to the Press Air Doordarshan, and then other users, local representatives, this data it will be given. Okay. So that can be, here there is another chart. The present system, this is a present system, how the data which is there, it will be distributed to many agencies, even to the people through radio, Doordarshan, all these things, media. So everybody is involved here. Everybody is involved here, and ultimately nowadays the data transmission, forecasting is very fast. Forecasting is very fast. Okay. The scope, what is the scope of this flood management? Use of remote sensing and JS. This is what is a present this thing, where we can say that the real-time data it can be used for the forecasting. Research and development, the institutions in India like the meteorology department, weather and rainfall forecasting, it is also there. Modeling is also there. Capacity building, that is people, they will be made aware about this flood situation. Then flood forecasting network, it will be there. Covers major and interstate river basins. There are 166 stations throughout India. There are 7 inflow stations, whereas 139 stations they are there for the forecasting. So for different areas, the forecasting stations they are being developed now, which are giving or which are alerting people from the area. Okay, so this is the number of forecasting stations in the different rivers. For example, maximum forecasting stations they are there on the Ganga River, the west flowing rivers, then the eastern flowing rivers, Krishna, Mahanadi, Bharat, whereas few of them they will be there on some other rivers also. Okay, but majority of these rivers, Ganga is having mainly major stations, forecasting stations for this. Major forecasting stations, they are there for this. Okay. Just a minute. Now these are the forecasting stations which are there at the different states, UP, then Bihar, Assam, AP. In Maharashtra, there are 6. So like this, all the states, they have these forecasting stations which are giving forecasting of the weather. Weather forecasting, it has been given by this. Just a minute. Now these are the activities which will be done during the flood management. There are some activities that will be done during the flood, before the flood. Means the forecasting, it will be given that the very big this thing, rainfall, it will be there, and evacuation. All these things, there will be pre-flood. There are some activities, management activities, that will be done during the flood. And there are some activities post-flood. Because once the flood comes in the area, the whole area, it has been with the mud, covered by the muds. So all these activities, they have to be taken here. Okay. Future strategies, they are also there. Focused approach, they have to get. Basin-wise action plan. Then floodplain zoning, role of central government, then the funding of planned flood management work, as well as the adequacy of flood cushion reservoir. All these are the agencies where the funds they'll be given to this, and everybody at their own, they will be working for the flood management. Okay, so this is a table that what activities you have to take it before the disaster, flood disaster, during the flood disaster, and the after the flood disaster. I will not read it out because we have 5 minutes to go. There are a few slides here. There is a disaster risk management program is there, which will be developed. Lot many agencies throughout the world, they are working like this. UNDP, USAID, and European Union, they are working for this, as well as Government of India also working for this. Okay. So these are the agencies, they'll be there working for the disaster risk management of the flood. Okay. So thank you very much. But before stopping, just I wanted to show you some pictures of the flood disaster. So these are the flood situation in 2021 in city of Kolhapur. So this is the National Highway 47, NH 47 from Pune to Bangalore. It has been closed for 15 days because of this flood. Here there is the Panchanga River. Here, this is the river basin. This is the river basin, but all the area it has been covered by the flood. So these are all areas covered by the flood. Okay. So this is rescue activity which has been carried out by the NDRF Jawans. Okay. So this is rescue activity during the flood situation. Okay. So these are some of the pictures. So many people see this is the post activity, post flood activity in Kolhapur city. This is the petrol pump. And this is what has happened by this flood. Okay, so this is the flood situation which has been occurred in Kerala. Within a very short period of time of 15 days, not much of the flood, the rain, it has come. The dams in this area, they will be fully packed, and this the rain, it occurred in the month of August. The dams were full. The rain was continuous, and because of that, the water from the dams, it has been released, as well as the storm water, it came, and all the situation, it was worsened that time like this. Okay, and these are the comments which have been given by the different people. This is a comment which has been given by a scientist of IITM, that he is saying that the water in the dams, it should have been released before. The same thing it has been said by the other person. This is Kerala map, and these dates also they have been given. So this is the disaster risk reduction expert. He been called and he has taken some actions, but till that time, This is August 9 to 15. Most of the taluka districts of the Kerala, they have been flooded. Okay, and this is the Environment and Climate Disaster Management Division NIDM person Anil Gupta. This is 16, 17. The entire Kerala, it was flooded. Okay, so this situation, it has happened in these two areas. At many regions, it happens. So thank you very much for attending this particular lecture on the flood disaster management. Thank you very much. We'll be having a break of 15 minutes. Again, after 15 minutes, we'll be rejoining. Thank you very much. Hello.
Sir. Good afternoon.
Good afternoon. I'm audible. Am I audible?
Yes, sir.
Oh, yes, sir.
Yes.
Yes, sir.
Okay. Shall we start?
Yes, sir.
Yes.
Okay. So we are going to start with the second lecture, which is a global disaster, we can say. So when I'll start speaking, you will understand why this particular type of topic it has been taken in a refresher course like disaster management. Okay. So there is a concept called as carbon sequestration. And further to this, I said, what is the role of academic institutes in this particular carbon sequestration? So slowly we'll go down to this particular idea of this carbon sequestration. But initially, I will tell you that what exactly this carbon sequestration it means. The carbon sequestration is nothing but to absorb carbon from the atmosphere and convert it into the biomass. Okay, conversion of gaseous carbon into the biomass. You know what is a biomass? It is nothing but the weight of the living creatures. Okay, so who is exactly absorbing this carbon from the atmosphere? It is nothing but the plants. So absorption of carbon in the form of carbon dioxide is considered as the carbon sequestration. Okay, so slowly you will come down to the idea of this carbon sequestration and how the academic institutes where we work, they have their role in the process of this carbon sequestration that we can understand. Okay. So now we can start with this, our formation of the earth. Now, as all of us, we know, there are a lot many number of theories. For example, Big Bang theory, that people, they may say that the Mother Earth or the planet Earth, it has originated around 4.5 billion years before. And when this Earth was formed, it was what we can say a separated, what we can say hot globe of the Earth. The temperature was very high. It is around 1100 degrees centigrade. Continuous lightning was there, as well as the, what we can say, the raining also, it was there during that particular time, even in the hot climatic condition. Okay, so what we can say, this earth was a typical structure which has been separated from the sun. Okay, so the birth of the earth, it was around 4.5 billion years before. The condition was totally different, but slowly this condition, it started changing. Okay, and how this has got changed, that the things slowly they got changed. The temperature was there, slowly the temperature it came down because continuous raining was there, continuous lightning was there. Now, because of all these things, the material which was there on the earth, okay, it was in its original form. As we know, in a periodic table, there are around 140 elements now. So these elements during that time, it was what we can say in their original form. For example, carbon was in the carbon form, hydrogen, oxygen, nitrogen, and all others were there in the original form. We called it as the primal matter. And this primal matter, it started reacting with each other. Okay, for example, carbon and oxygen reacted and they form carbon dioxide. Hydrogen, oxygen, it reacted and they form water. NH, that is nitrogen, hydrogen reacted and they form the ammonia, like this, methane, all these things they have been formed. And slowly, this original primal matter, which was there in its original form, it started getting changed into the complex forms. For example, from the carbon, hydrogen, carbon, oxygen, carbon dioxide form, carbon, hydrogen, methane was formed, ammonia, hydrogen, the ammonia was formed. Like that, many things they have been formed. Slowly, a complex things they started forming on the Earth's surface. Okay, slowly they got changed. Again, further complexity it has happened, and the materials like what we can say, the monosaccharides, the what we can say amino acids, then there will be formation of the glycoproteins. So basic chemical materials they were formed, and ultimately there is development of the DNA, RNA, that is nucleic acids, then the glucose, that is higher carbohydrates, then the proteins from the amino acids has been formed, and all these complex materials they have formed, and ultimately by this, these three things they have been developed. The atmosphere, it started consisting the gases. Now we know the composition of these gases. Lithosphere, it was formed, which was been constituted with the soil, and hydrosphere, it was also formed. Okay, and slowly from this particular thing, the first cell, it has got evolved in the water. And with the development of the first cell around 3.8 billion years before, the first cell in the water body, that is in the sea, it has got developed, and slowly what has started happening, that this first cell, it started evolving. The evolution process, it started, and by the evolution of this first cell, the complex living creatures or the complex living organisms, they form from the first cell. The protozoans, they have got developed. From the poriferans, they have been formed, the coelentrates, then the annelids, platyhelminthes, then arthropods, like this. Slowly the evolution in the animal life, it has got developed. Then in the plant life again, from the algae-like plants, the further higher angiosperm-like plants or the trees, they got developed. And we call all this together with atmosphere, lithosphere, and hydrosphere. We called it together on the Earth's surface as the biosphere. So till the process of evolution, it was continued. And by the process of this evolution, all the different types of the organisms, they have been developed on the Earth. One of that is the human beings. Okay, we know that these human beings, they have been developed on this Earth, or evolved on this Earth 5 to 7 million years ago. Now, if you see the evolutionary history of the human beings, there were different stages of evolution or the steps of the evolution. And here, during this understanding these stages of evolution, you can see this Australopithecus. And if you see this Australopithecus, this particular stage of the human beings, it was just like an ape. If you see the brain size, this is the cerebrum of the brain, and the folds on the brain, they are little. Means the intellectual capacity of this Australopithecus was less. It was just like an ape. And because of that, what usually we say that the ancestor of the human beings is the apes. Okay, they were walking on the four legs like that. And the tail was there, and slowly it has got transformed into the Australopithecus. You can see from the Australopithecus, Homo habilis, it has got developed. You can see the cerebrum part of the Homo habilis, the folds that got increased. It denotes that there is development of more intellectual power. Again, the Homo erectus, fully erect individual or the stage developed. And here you can see the folds again on the cerebrum, they have got increased, which denotes that the intellectual capacity of the human beings, it has got increased. Then further to this, Homo neanderthalis or Neanderthal, it has got developed, who has more folds on the cerebrum, increased intelligence, and again from this Homo sapiens, the modern man, it has developed, which is having more folds on the cerebrum and more intellectual power it has got there with this Homo sapiens, and this power it was been used by the Homo sapiens, the modern man, and many things they have developed. Many things there. They are considered, this Homo sapiens in the older times, they have been considered as the hunter-gatherers. Hunter-gatherers means slowly, as the evolutionary development has happened with this Homo sapiens, with the different stages, or through all these stages, the human beings, they have gone. Here you can see they used to do the hunting, the stages. They started living in the caves. They have painted on the walls of the caves. Then started moving from the gathering or the staying near the river banks. Movement in the river, cultivation, shifting from one place to another place, use of cattle, or the adoption of the animals for the work. Then hunting, all these things with the evolution of the man, it started. They started doing agriculture, and for the agriculture, they started using cattle, horses, etc., etc. And then after this evolution of the agriculture, it led to the industrialization. Around, we say, 250 to 200 years, the industry for the production of many things which are useful for the human beings, it started on the earth's surface by the Homo sapiens, that is developed or the evolved human beings. And this industrialization on the earth, it started adding many things into the atmosphere of the earth, in the lithosphere of the earth, as well as the hydrosphere of the earth. Okay, and this has happened because of the development of the biosphere, development of an animal like human beings. Okay, so human beings during its evolution, it has gone through all these stages leading to the industry. Okay, so if you see this Earth's atmosphere before origin of living organisms, it was having water vapors, carbon dioxide, nitrous dioxide, sulfur dioxide, as well as few particulate matter. It was there on the earth, in the atmosphere. Okay, even the particulate matter was there. But after origin of living things, many more things they have been added to this. So these things were there already existing, but the gases like methane. Now, from where this methane it comes? The methane it comes by the
এদিকে মহিলা কমিটির কি আছে,
decomposition.
এদিকে পাঁচটা ডিপার্টমেন্ট ছাড়তে
Decomposition of the organic material. Methane, they started releasing the decomposition of the material which has been used by the human beings. It started decomposing, and the methane like gases, they will be added, as well as some gases they have been produced by the human beings, and they will be added into the atmosphere. And because of that, what we can say, the atmosphere, it was not like how it was there before origin of living organism. It got changed. Some more things they have been added into this atmosphere. More things they have been added into the atmosphere. Now, if you consider this particular atmosphere of the earth, and if you try to understand the composition of these gases, we know that around 78% of these gases is nitrogen. Okay, now what is the characteristic feature of this nitrogen? This nitrogen is always cold. Okay, and you know the characteristic feature of this nitrogen, it is very cold, and because of that, even a tissue, the sperms, ovas, they can be stored in the liquid nitrogen. We fill nitrogen into the tires, okay, so that these tires, they will not be hot and they will not be no more friction because of the hotness. So nitrogen is cold. Okay, as well as 21% of the oxygen it is there in the air or the atmosphere. So these two gases, nitrogen as well as oxygen, both these gases, they are cold. They are not absorbing heat. They are not absorbing heat. So they are not hot, they are cold. Whereas 1% of this is the trace gases. Okay, so nitrogen and oxygen is around 99%. Okay, and they don't absorb or reflect sun rays, and because of that they are cold. And what further we can say, the Earth's atmosphere is controlled by remaining 1% gases, that is trace gases. Okay, and a small increase in these gases can change the temperature of the Earth. Means if these gases, they are changing, the percentage of these gases will get changed. These gases, if the percentage gets changed, the heat will be absorbed by these gases, and there is a possibility of change of Earth's atmosphere. The temperature of the atmosphere. That is what a change because of 1% of gases which are there in the atmosphere. Okay. Now, there are three concepts to understand here. The first concept is greenhouse effect, second one is global warming, and the third one is the climate change. These are the three concepts. Now, what exactly is the greenhouse effect? Now, we know that the sun rays, they are coming from sun towards the Earth's surface. And here is this stratosphere, which has been covered by the ozone. Okay, above 16 kilometers from the Earth's surface, here there is a ozone layer, and this particular area we are calling it as the stratosphere. Now, what will happen? That the sun rays, they will enter through this ozone layer into the stratosphere. They will fall here. Some of the sun rays, they will be absorbed. Some of the sun rays, they will be reflected back. They will go back into the atmosphere. They will go back into the atmosphere. Whereas some of them, they will be trapped. They will be used by the green plants, and this sun rays or the sunlight will be converted into the food. Okay, or we can consider it as it will be converted into the energy, whereas some of that it will be there in the atmosphere, in the stratosphere. It will fall on some substances which will be absorbed by some gases, and the temperature of the atmosphere, it remains hot, or we can say normal. Okay, if the percentage of these gases, it remains constant, for example, carbon dioxide is 0.03%. If it remains constant, here, what will happen? This temperature or this rays which will be absorbed by these gases will maintain the temperature of the atmosphere. We need to have 37 degrees centigrade of temperature for normal activities, physiological activities. So this temperature, it will be maintained by these gases. Now, if these gases, if they get increased, now reason why these gases will get increased is the vehicular exhaust, the industries, respiration. If all these things, they will be increased locally. For example, wherever you are staying, in that particular village or city, if the vehicular exhaust, if it is more, industries, they are more, what will happen? These industries, vehicular exhaust, or the people, they will release more amount of carbon dioxide here. And what will happen? This particular area of the region will get hot. The effect is local. And this local effect is considered as the greenhouse effect. What is a greenhouse effect? It is a increase in the temperature of the local area, and this effect is considered as a greenhouse effect. And the same is the case that this greenhouse gases like carbon dioxide, methane, nitrous dioxide, CFCs, they will get increased in the area and the temperature will get increased, and this increase in temperature we call it as the greenhouse effect. Okay, so the next concept, it is the global warming. Now in this global warming, again we can say sun rays come through atmosphere on the earth surface. Okay, some sun rays are used for photosynthesis, water vapor formation and other purposes, and most of the sun rays get reflected back outside the atmosphere. Some of the gases stop these rays going out of the atmosphere and keep earth warmer. That is, as I said, the ozone, okay, the upper layer of the stratosphere. And the gases, those are keeping this earth, what we can say, the temperature, normal temperature of this, they are called as the greenhouse gases or the GHGs. This constant temperature is required for the survival of the living organisms. The temperature is required for the survival because the physiological activities of the organisms, it takes place in this temperature. And for that, this greenhouse gases, like carbon dioxide, methane, nitrous dioxide, they will be responsible. Okay. And further, we can say increase in these greenhouse gases leads to increase in temperature of the earth, and it is called as the global warming. In the greenhouse effect, what happens? The temperature, because of these greenhouse gases, it will be there increased in the local area. But here, throughout the world, these greenhouse gases, they will get increased, and because of that, the temperature will increase throughout the world, and this warming of the earth throughout the world is called as the global warming. The temperature is increased globally, and because of that, it is considered as the global warming. The process is considered as the global warming. Okay, so here are some gases. If you consider 1% as 100%, out of that, carbon dioxide, which is a greenhouse gas, it is 63.5. Methane, it is 20.5. Nitrous oxide, it is 4.5, and the CFCs is 11.5. This is a breakup, and from that, this carbon dioxide, which is there, been released by industries, vehicular exhaust, as well as the respirations and all, it is maximum, that is 63.5. And because of that, whenever we talk about global warming, greenhouse effect, mostly the culprit which has been taken into consideration is the carbon dioxide. Okay. Now, what are the sources of these gases, greenhouse gases, that is GHGs? The first is the natural sources, the respiration. We take the normal air. From the normal air, we use oxygen at the cellular level and we give out carbon dioxide. So all the living creatures, including plants, during the daytime, they will be responsible by the process of respiration. They are releasing carbon dioxide into the atmosphere. That is a natural source of GHGs. Ruminant animals, the cattle, like cows, buffaloes, what they do, they feed on the food, and whenever they have time, this food will be stored in the rumen of the stomach, and whenever they have time, it will be taken again into the mouth and it will be crushed. During that particular time, from the mouth of these cattle, the gas will be released, that is nothing but the methane. It is a methane. So ruminant animals, then aerobic microbes. Most of the decomposition has been done by the aerobic microbes. Okay, wetlands where lot much organic material will be there on the banks of this wetland, where decomposition of this organic material takes place. Then forest fires. They are releasing carbon dioxide into the atmosphere, as well as volcanic eruptions. They are also leading to add more carbon dioxide into the atmosphere. So these are the natural sources, whereas the man-made sources, they involve automobile exhaust. That is the maximum source of the carbon dioxide. Okay, gases emission from the industries, it also has a maximum share. Power plants, domestic fuel burning, then the man-made forest fires, dams, paddy fields. Why these dams and paddy fields they have taken? Because usually in these dams, the banks, they have organic material, and this organic material in paddy fields as well as in the dam, it will get decomposed, and from this decomposition, methane will be released. And at this particular time, I can tell you that US-like countries, they say that India, it is a maximum producer of paddy, that is rice. And this rice it will fall in the soil, it will get decomposed, and the methane will be released. And because of that, the main culprit of this global warming is a country like India, which is producing maximum paddy. Okay. Then refrigerators, body sprays, they have these CFCs, fire extinguishers, all of them, they are nothing but the man-made sources of the greenhouse gases. Now, if you see the percentage in the last 100 years, the carbon dioxide, it is increased by 31%. Methane, it has been increased by 151%. Nitrous dioxide, it has been increased by 31%. Okay. If you see this increase in the gases, this increase is leading to the increase in the temperature. If you see from 1880, the greenhouse gases at many point of time, they have increased, decreased, increased, decreased. You can see from this graph. Okay, at many times it has got increased, again it has got decreased, and because of that, a very small rise in the temperature is there. But if you see after 1980, this percentage of carbon dioxide released into the atmosphere, it has got increased, and around 1 degree centigrade temperature, it has got increased throughout the world. And it has impact on many things. Many things, they have been affected by this. Okay, so global temperature, because of this global warming, it has increased average throughout the world by 1 degree centigrade. Okay, now if you see this particular trend of the carbon dioxide in the atmosphere and the temperature of the earth, see, this is a graph which is showing the different eras of the earth period. Okay, so this is the minus 10 million years before, age of dinosaurs. You know the dinosaur size, very big animals. Okay, but these big animals, because of this temperature fall, they have been totally extinct now. But what you can find here, the animals which have been evolved that time, they died because of the drop in temperature. But the animals like this arthropods, like cockroaches, they survived. And the further evolution has taken place. Now you can see here by this graph that this temperature during a particular period of time in the years, the over time period, the temperature, it was got increased, decreased like that. And you will find that in the 20th century, the temperature, a little increase we have observed. But after that, the temperature slowly, it is increasing only. It is not going down. But in future, we cannot say whether the temperature is going to go down, whether it is going to remain stable, or it will increase slightly, or it will increase tremendously. Nobody knows. Because if you see the history of the earth and the temperature, there is a fluctuation of this temperature. And the same thing, it is happening. The carbon dioxide percentage, it is increasing, greenhouse gases, they are increasing, and ultimately the temperature is also increasing on the earth's surface. Okay, now based on this, there is another concept, that is of the climate. Now what is a climate? Climate is an average of weather. Now what is the weather? Temperature, rainfall, humidity, etc., etc. But it will remain for at least a long period of time, that is 2-3 years. Okay, and it comprises or encompasses the temperature, humidity, atmospheric pressure, winds, rainfall, atmospheric particle count, and the numerous other meteorological elements. Now, if you see the climate of our country, we will have six different types of climates in the different regions because of the altitudes, the geological strata which is there in the area. For example, we have highlands, we have humid subtropical regions, tropical regions, arid regions, semi-arid regions, tropical regions, like this. All the different areas they have been seen in our country. And because of that, the climate of our country in the different regions, it is different. Climate of our country in different regions, it is different. So this is one concept. This is one concept. And on the basis of that, we have the seasons. We have 4 seasons. For example, winter, that is Shishir. It is ranging from December to February. Grishma, that is summer, from March to May. Monsoon, that is Varsha, from June to September. And post-monsoon, that is Sharad, it is October and November. So 4 seasons are there. And in these seasons, the climatic conditions throughout, they are of similar type. And because of that, they are considered as the seasons. But the climate during this particular seasons also, it may change. And this change, it may be because of many factors. There can be extraterrestrial factors or the earth climatic factors, atmospheric factors. Okay, and this changes, they will be because of these two: solar output, earth sun geometry, interstellar dust, etc. They are the external factors, whereas these are the factors on the atmosphere of the earth, that is volcanic emissions, mountain building, the continental drift, atmospheric ocean heat exchange, then the surface reflectivity, atmospheric chemistry. All these factors, they are changing this climatic condition. The gases like carbon dioxide, methane, then the nitrous dioxide, CFCs, as well as water vapor, they are changing the whole thing. Even these seasons, they'll be changed by these gases. The seasons, they'll be changed by these gases. And this change which are occurred in the atmosphere or on the Earth's surface, we are considering it as the climate change. Okay, so this climate change is a problem related to changes in the concentration of the greenhouse gases, that is GHGs. What are these? Water vapor, carbon dioxide, methane, nitrous dioxide, and CFCs, which trap infrared radiations from the Earth's surface and thus cause the greenhouse effect. Okay, so these are the changes which are taking place in the climatic condition. We are nowadays calling it as the climate change. Whenever there is a storm, whenever there is a rise in the heat, what we call it is because of climate change. So there are these 3 concepts. First is global warming. It is a local warming. Global warming, that is globally the heat will be there. And this heat leads to climate change. And because of this, many things they happen. What is going to happen? Extreme weather events. Means during the winter season, there will be very hot condition. Okay, we can say abrupt swings, extreme weather events. The second thing is more frequent and powerful cyclones and hurricanes. You must have heard, you must have seen on TV, read in the newspaper that on the East Coast, lot many cyclones and hurricanes, they are coming. And like Western countries, now we are giving names to these cyclones and hurricanes. Okay, more frequent and intense floods and heavy snowfalls, they are also happening. It is because of this climate change. Severe and longer drought period, that can be also there. Unexpected climatic events, which we experience now, they are also because changes in the weather pattern. Means usually in our country, in the month of June, there will be a rainy season. But nowadays you will find that in June, there will be no rain. Actually, the rain starts in July. So changes in the weather pattern, it has also happened. Short winter, early spring, longer summers, all this we are nowadays talking that it is because of the climate change. Okay, now what are the mitigation and adaptation strategies strategies? what are the adaptation strategies for this climate change? Okay, the first thing is mitigation. First thing is mitigation. And in this mitigation, there will be reduction in the carbon dioxide emission. And as I said, carbon sequestration, which can be done by vegetation, soil, and the ocean. Whereas adaptation, it is by resiliency farming, disaster risk reduction, and the coastal area prevention. These are the adaptations they can be done. They can be done. But we are focusing on this carbon sequestration to combat this climate change, mitigation of this climate change. Okay, so what exactly the carbon sequestration is? Carbon sequestration refers to the capture and long-term storage of carbon in forests, soils, or in the oceans, so that the buildup of carbon dioxide, which is one of the principal greenhouse gas in the atmosphere, will reduce. What is the basic principle? To trap the carbon dioxide from the atmosphere to reduce it. So reduction of carbon dioxide from the atmosphere and storing it somewhere, either in the forest, soil, or in the ocean. We are calling it as the carbon sequestration. So this is one of the way of mitigation of the carbon or the global warming and the climate change. There are three ways. The first one is the carbon sequestration in the terrestrial ecosystem. What is this? Increasing the amount of carbon storage in vegetation and soil. That is terrestrial sequestration. The second one is the carbon sequestration in ocean. That is oceanic sequestration. So you can store this carbon dioxide in the oceans. And the third one is subsurface sequestration. That is geological sequestration. That is, you can deposit this carbon in the soil. Okay. And where this carbon is stored is considered as the sinks. So sinks refers to the storehouses of the gases or the places where they can be sequestered. What is sequestration? It is deposition. Okay. So the oceans are perhaps the biggest sinks and contains about 40 gigatons of carbon. By contrast, the atmosphere contains only 750 gigatons. And the terrestrial, it is 2200 gigatons. Okay. It means we have a very good scope of storage of this carbon in oceans. Okay. So vegetation and soil also have the capacity to sequester carbon. Soil also removes methane to some degree. That is what we can say for these things. Okay. So there are these different ways of sequestration of the carbon. Okay, carbon sequestration in soil and forest, carbon sequestration by ocean fertilization, carbon capture by large power plants, air capture, then geological carbon sequestration. These are the various ways of sequestration of the carbon. There is first sequestration, that is nothing but the oceanic sequestration. That is the major sequestration, which happens by two methods. The first one is the direct injection and the second one is the artificial process. Direct injection is the man-made method. The carbon which has been produced here, it will be brought here and it will be injected directly here at the base or left through this boat or the ship at the interior areas of the sea. Okay, that is what we call it as the direct injection. Whereas there is oceanic fertilization. Okay, because of the waves, this carbon dioxide will be mixed. It will get converted into the carbonic acid, and this cycle will take place, which also sequester the carbon naturally. But these are the artificial ways, whereas these are the natural ways of the sequestration of the carbon. Okay. So this is the geological carbon sequestration. This is the geological carbon sequestration, and this geological carbon sequestration, this is the industry or a power plant from where this release of carbon dioxide will be brought to one place where this carbon dioxide will be captured through pipeline. It will be compressed in a unit and ultimately in the geological bore, this carbon dioxide will be injected. Okay, so this process is injection of the carbon dioxide into the soil strata, which is considered as the geological carbon sequestration. The next part is the terrestrial sequestration, and this terrestrial terrestrial sequestration is the vegetative sequestration, and that is usually take place by the photosynthesis. We know, all of us, we know the process of photosynthesis where the carbon dioxide will be used with the help of this water and sunlight. It will be converted into the glucose, that is C6H12O6, and the release of oxygen will be there. There is a release of oxygen. So carbon dioxide is converted into glucose, that is the food that will be produced by the green plants in the chlorophyll molecule, and there is release of oxygen. And this process, we are considering it as the process of photosynthesis. This is considered as terrestrial sequestration. Okay. Now, by these three methods, there is a possibility of sequestration of the carbon dioxide. Now, what is the role of the academic institute? How they will be useful for combating this climate change by sequestration of the carbon dioxide? What they can do? The first thing they can do, training on reduce, reuse, recycle. Wherever there is a lecture on pollution, always people, they talk of reduce, reuse, and recycle. Minimum use of the resources, reduce use of resources. If they are used, reuse them as well as recycle them, which will be reducing carbon footprint. Means release of carbon, it will be reduced. Awareness amongst the students. Students, they will be made aware that we are responsible for the release of carbon dioxide. To reduce the carbon dioxide, these things you should do. That awareness amongst the students, they can be done by the academic institutes. Respect and protect green spaces. If the green spaces, they are there in your campus, they can be protected. These spaces, they can be protected. Plantation drives, use of cycle and public vehicles for transport, give practical experience in combating global warming and climate change. So a lot of workshops, they can be arranged like this. Now, to do all these things, one experiment has been carried out in our university, Shivaji University. We have conducted that how the carbon sequestration can be done, and how this carbon sequestration can be measured in the academic institutes. That is what one experiment, it has been carried out by the students of MSc Environmental Science. So here I'm going to present a role of academic institution in carbon sequestration, a role model of carbon sequestration, that is Shivaji University, Kolhapur. Now here what picture you can see is the picture of campus of Shivaji University. It is a very green university. In due course of this, what I am going to talk, you will understand that how many trees they are there and how these trees, they will be responsible for the sequestration of the carbon dioxide. Okay, so one experiment, it has been carried out in Shivaji University. Carbon sequestration assessment of Shivaji University campus, Kolhapur, a case study. This has been carried out by the student. Now, as we know, academic institutes, universities, national and international organizations are established on quite large areas and possesses good amount of green cover. This green cover acts as sink for atmospheric carbon dioxide. So this academic institution campuses, they can be acting as the sink for storage of carbon dioxide. This carbon sink pockets situated at various organizations need to address and conserve to increase rate of carbon sequestration in addition with betterment of surrounding. So it is the betterment of that particular university. Now, if you take example of Shivaji University, Shivaji University campus covers around 853 acres of area having patches of woody vegetation, grasslands, and water bodies along with built-up area. Okay, it is necessary to calculate the carbon sequestration potential of this area to underline the capacity of campus as a possible carbon sink to conserve and increase its vegetation. Okay, now what objectives we kept in mind? To study the woody green cover of Shivaji University campus, because nobody knows that how many trees are there. Woody green cover, it is there in the campus. What we decided to understand that how much woody green cover it is there on the campus. to study species diversity of woody vegetation on the campus. Species diversity also we try to understand biomass and carbon stock accumulated by woody vegetation of the university campus, as well as to explore carbon sequestration potential of woody vegetation on the university campus. That is the main objective of this. And to explore oxygen release, that is also very important, because these trees which are there on the campus, they are absorbing carbon dioxide and they are releasing oxygen. So this objective also it has been taken to explore oxygen release potential of woody vegetation of university campus. So 5 objectives they have been taken for this particular experiment by the student, guided by our faculty. The methodology, it was very simple. A field survey it has been carried out. Study area of 853 acres was divided into 46 sectors with the help of Google Earth image. Now you can see that these are the 46 sectors. These are numbers which we have given for the sectors. Okay. So by Google Earth image, we have divided into 46 sectors. A tree with girth. What is a girth? It is a circumference of stem more than 10 centimeter at chest level. That is around 4 feet height. 4 feet height was taken into consideration. If this characteristic is fulfilled by a tree, it is considered as a tree. Okay. A tree with girth more than 10 centimeter. If it is having 10 centimeter diameter of this, then it is considered circumference, not diameter, circumference. It is considered as a tree. Girth of each tree has been measured with the help of measuring tape and approximate height by visual. Approximate height by visual method. The height is also calculated so that you can understand the canopy. There are formulas. Identification of tree species has been done with the help of field guides, web source, and with the help of expertise of the botany department of Shivaji University, Kolhapur. And this data analysis, we have not used any model or any software, just on MS Excel spreadsheet we have all this, but the factors and the formulas which have been used, they will be given by IPCC, that is Intergovernmental Panel on Climate Change, an international body. They have given factors as well as the formulas, because each tree, the biomass, it is not having the same density. And because of that, to calculate the carbon sequestration, each tree will be having different, what we can say, the different factor it is there. Different factor it is there. Okay, so this is a study area and long, and 45 it has been divided. 46 sectors divided. Okay, and the tree census it has been carried out. For each this thing, 2 students they have been allotted. Particular what we have given a format has been made where this particular students in each sector, 2 students they have, and they have measured all these trees actually. Okay. This is a 4 feet height, and the students they are taking the measurement. The students they are taking measurement. Okay. So this is a data collection throughout this campus of 853 acres. The students they moved. Once they complete the measurement, they have made a mark on this tree by color. Okay, so that the other group will not come and again measure it. Okay, so these are some of the formulas for this. For the biomass of a tree in grams, volume of tree into specific gravity density of tree. Okay, this is a formula. Okay, so specific density of tree, for each tree it will change, because some of the trees the wood is thick, the density is more, whereas some of the trees the wood is light, density is less. Okay, then carbon stock, it will be measured in tons, the biomass, that is total weight, into carbon stock factor. This is 0.5. Okay, this factor is common throughout world. It is given by IPCC, Intergovernmental Panel on Climate Change. Carbon sequestration in tons, that is carbon stock into carbon sequestration factor. This is a carbon sequestration factor, that is 3.67. And oxygen release is carbon sequestration to oxygen release factor, that is 2.67. So these simple formulas, they'll be used by the students. Okay. And they came down with some observation. Okay. The first observation is species with highest population. See, these first 5 species, they have been taken. These are the botanical names. That is Giri Pushpa, they found it is 4,235. Subabul, they found 1,850. Neem 951. Nilgiri 902. Rain tree 675. And some miscellaneous trees, they were also there. But these 5 trees, they are major. And total count, it was 13,472. Out of this, maximum species or the trees of this Giri Pushpa or Undir Mari, we call it as, it is 4,235. Okay. So this is the first observation. The second one is species with highest biomass. Now, even though here this Gliricidia, that is Giri Pushpa, it is having total number of trees, they are more. Here you can observe that the biomass, it is more in case of this neem, shiris and neem tree. Okay, Giri Push, it has gone down because the density of wood, it is less. And the total biomass in tons is 4,233. Okay. Now, next is species with highest carbon stock. That is biomass into the carbon stock. Here, again, you can find that these 5 trees, they have this much of the carbon stock like this. Whereas the total carbon stock of the Shivaji University campus is 2,116.66 tons of this trees were there. And on the basis of this, carbon sequestration and the carbon liberation has been calculated. And it has been found that Gliricidia, the carbon dioxide sequestration is 3,897 because number of trees were more. Whereas oxygen release is again more by these trees. Subabul, it is this much, oxygen release is this. And actually carbon sequestration by all these trees is 7,768 tons of carbon dioxide will be absorbed by these trees, whereas oxygen liberation is 17,803 tons of oxygen. It will be released on the Shivaji University campus. So maximum amount of this carbon dioxide is been released by the trees which are there on the campus. Now here, one thing we should remember, that only trees, they have been taken into consideration. Herbs, shrubs and grasses, they have not been taken into consideration for this calculation. Okay. So ultimately, what conclusion we have is Shivaji University campus has sequestered 7,762.15 tons of carbon dioxide and has released per year 17,803.66 tons of oxygen. Okay. So in conclusion, what we can say, total number of trees on campus, that is 853 campus, is 13,472. Species counted of these trees is 99. Annual carbon sequestration by woody trees is 7,768.15 tons of carbon dioxide. It will be deposited or sequestered, and oxygen release is 17,803.66 tons of oxygen. And the conclusion of this is, it is assumed that a single tree support oxygen demand of 2 people for their life. Okay, therefore 13,472 woody vegetation present on Shivaji campus is supporting 26,944 people on and around the campus, and because of this, Shivaji University campus is working as a good carbon sink and a productive oxygen for park for the Kolhapur city. That is what is the ultimate conclusion. Okay, and for this, as we are considering this global warming as the world disaster, we have to think globally, act locally, and practice personally. Means we have to start to release minimum amount of carbon dioxide into the atmosphere. Then only it is possible that this Mother Earth, it will not become more and more hot, but it will sequester more and more carbon dioxide. And this is all it is for the protection of our Mother Earth. Okay, thank you very much. I think there will be a session of question answer. If you have any questions, definitely we can answer them. If you have questions, you can ask it. Any question? Any question? Anybody has a question for both the sessions?
सर एक प्रश्न होता. हॅलो
Hello.
आवाज येतोय
Let them
सर? हॅलो
Hello, बोलो.
हा सर आवाज येतोय. सर एक प्रश्न होता. नर्मदा नदीच्या बाजूला जो खडक येतोय तो लाल कलरचा येतो, तो कशामुळे असेल?
कुठल्या नदीच्या?
नर्मदा ओंकारेश्वर.
काय येतोय?
खडक जो दिसतोय तो लाल कलर मध्ये दिसतो, तर त्याचा इफेक्ट नदीचा आहे की कसला आहे?
नाही, तो युजली काय आहे, जो पाण्याला कलर येतो तो आजूबाजूच्या मातीचा असतो. युजली तो मातीचा असतो, म्हणजे त्याला दुसरं काही तुम्हाला रिझन असं देता येणार नाही. पण बऱ्याच वेळी समुद्रामध्ये, नदीमध्ये फारसं होत नाही. इफ देर आर रेड आल्गी, लाल कलरच्या आल्गे जर असतील काय, तर तो कलर येऊ शकतो. पण युजली नदीमध्ये एवढं आल्गे वाढत नाही, कारण फिश भरपूर असतो. ते आल्गे खाऊन टाकतात. आणि त्यामुळं जो कलर येतो तो युजली कलर हा मातीचाच असतो. पार्टिक्युलेट मॅटर, त्या भागातली माती जी असते त्या मातीचा कलर पाण्याला युजली येत असतो.
हो सर, हो. आणि एक प्रश्न असा होता की गावाच्या ज्या नद्या असतात छोट्याल्या, तर त्याचं खोलीकरण करण्यासाठी गव्हर्नमेंट सांगत असतं, त्या खोलीकरणाचं कारण काय असतं?
नाही, आता ऍज अ एन्व्हायरमेंटलिस्ट आपण एखाद्या नदीचं पात्र खोदून ते रिकामं करणं ना, हे बरं नसतं. काय ते सिल्टेशन आणि हे प्रोसेस आहे ना, नाही, इट इज अ नॅचरल प्रोसेस. मी सांगतो ते ऐका. नॅचरल प्रोसेस, तिथं आपल्याला काय करायला पाहिजे, इरोजन थांबवायला पाहिजे. कारण ह्या सिल्ट मध्ये आणि वाळूमध्ये, नदीच्या बेसिनच्या मध्ये बरेचसे ऑर्गॅनिझम्स असतात. बरेचसे ऑर्गॅनिझम्स असतात. जर ते तुम्ही वाळू आणि माती काढून टाकली तर ती नदी बोडकी होईल. तिथली जी बायोडायव्हर्सिटी आहे ती कमी होईल. पण आता असे ज्यावेळी नदी पूर्णच भरते, पात्रच पूर्ण अगदी सकल होऊन जातं, त्यावेळी हे करायला हरकत नाही. पण सगळ्या ठिकाणी हे करायची काही जरूर नाही, कारण ते इट विल बी हार्मिंग द एंटायर फूड वेब ऑफ द रिव्हर. फूड वेब रिव्हरचं ते ना डिस्टर्ब होईल.
ओके. आणि आणखीन एक सर, जी वाळू उपसा होते, तर वाळूचा उपसा झाल्यानंतर नदीचं नुकसान ऍक्च्युली काय होऊ शकतं?
नाही, सिल्टेशन किंवा वाळू असते, त्या वाळूमध्ये पण काही मायक्रो ऑर्गॅनिझम, काही अॅनिमल्स, प्लांट्स, त्याची रूट्स, हे सगळं असतं. आणि ती जर वाळूच जर तुम्ही काढून टाकली, देर इज ऑलवेज अ फूड चेन अँड अ फूड वेब इन अ अक्वॅटिक बॉडी. म्हणजे तो लेक असेल किंवा ती नदी असेल. सी द स्मॉल झूप, दी फायटोप्लॅन्क्टॉन्स, म्हणजे काय अल्गी सारखे जे असतात प्लांट्स, ग्रीन प्लांट्स, छोटे छोटे वन सेल, ते कोण खातात? झू प्लॅन्क्टॉन, छोटे छोटे अॅनिमल्स खातात. त्याच्यावर काय छोटे मासे जगतात, छोट्या माशावर मोठे मासे जगतात, मोठ्या माशांच्यावर बर्ड्स जगतील किंवा स्नेक्स असतील, काय असतील. सो ऑलवेज इट इज अ फूड चेन. त्यातले जर पहिला भागच निघून गेला, म्हणजे हे मायक्रो ऑर्गॅनिझम्स आहेत, फायटोप्लॅन्क्टॉन आहे, झू प्लॅन्क्टॉन आहे, ज्याची पैदास ही त्या वाळूमध्ये किंवा त्या मातीमध्ये होते, सिल्टमध्ये, चिखलामध्ये, ते जर काढून टाकली तर पूर्ण जी फूड वेब आहे, फूड चेन आहे, ती डिस्टर्ब होईल आणि नदी डेड स्वरूपाकडे जाईल ती. म्हणून ती वाळू काढू नये असं म्हणतात ते.
ओके, थँक्यू सर.
एनी क्वेश्चन?
हॅलो, नमस्कार सर.
हा, बोला.
मी असिस्टंट प्रोफेसर, एसपी कॉलेज, जॉग्राफी डिपार्टमेंट. डॉक्टर सुमित्रा निकम.
बोला.
मागच्या वर्षी आम्ही दूधगंगा, पंचगंगा आणि कोयना ह्या 3 नद्यांचा डिस्चार्ज आणि सिल्टेशन रेट याच्यावरती जिओ स्टॅटिस्टिकल अनालिसिस केलं. आणि जिओ मॉर्फोलॉजिकल, जिओ हायड्रोलॉजिकल.
ओके.
एका स्टुडंटचं डिझर्टेशन होतं माझ्याकडे. बट त्याच्यामध्ये ते करताना आम्हाला सिल्टेशन रेट हा जो कंपोनंट आहे तो त्याचा जो सेकंडरी डेटा आहे तो अवेलेबल होऊ शकला नाही किंवा तो दिला नाही आम्हाला CWC कडून. तर त्याच्यासाठी दुसरा काही वे आहे का की तो डेटा मिळवण्यासाठी किंवा तो कम्प्युट करण्यासाठी?
आता काय माहितीये काय, तुम्ही पत्र देऊन तुमच्या कॉलेजचं तिथं गेला तर तुम्हाला ते उभा पण करून घेणार नाही. हा डेटा गव्हर्नमेंटचा असतो, तो तुम्ही RTI मध्ये राईट टू इन्फॉर्मेशन मध्ये मागायचा असतो किंवा त्यांचे जे रिपोर्ट्स ऍक्च्युली काय आहे, RTI मध्ये मागितला तर तुम्हाला तो एक्झॅक्ट तुम्हाला कागदपत्रच द्यावी लागतात झेरॉक्स करून. रिपोर्ट मध्ये येईल तो तुम्हाला बऱ्याच वेळा मॅनिप्युलेटेड डेटा येईल. तुम्हाला जर गव्हर्नमेंट करता एक्झॅक्ट डेटा मागायचा असेल जो तुम्हाला करता येत नाही बिकॉज ऑफ लॅक ऑफ सम इक्विपमेंट ऑर समथिंग किंवा टेक्नॉलॉजी, त्यावेळी तुम्ही काय करायचं, RTI मध्ये त्याला कुणाला तर द्यायला सांगायचं. RTI मध्ये तुम्हाला सगळी इन्फॉर्मेशन मिळते सरकारी, आणि तुम्हाला ते असं नुसतं हे करून देता येत नाही. त्यांना त्यांचे रिपोर्ट झेरॉक्स करून द्यावे लागतात. फक्त काय त्या रिपोर्टला तुम्हाला पैसे भरावे लागतात, झेरॉक्सचे पैसे भरावे लागतात.
तरी अंदाजे सर किती दिवस लागू शकतात ह्या प्रोसेसला?
ते आता इट डिपेंड्स. ते एका महिन्यामध्ये पुरं करावं, जास्तीत जास्त 3 महिने. RTI चे नियम बघा ना, राईट टू इन्फॉर्मेशनचे.
ओके सर. ओके, थँक्यू सर. थँक्यू.
आणखी काही प्रश्न? I'll call this person.
कोट ऑफ थँक्स कोणाचं आहे?
माझा आहे मॅडम 36 नंबर.
रेडी राहा सर. सर कुठे गेले?
मॅम एनी क्वेश्चन? येस सर आहे.
मी आहे.
मॅम कोणत्या टँकचा किंवा एनी क्वेश्चन नाही का? क्वेश्चन झाले का सर? ओके. रोल नंबर 36.
Yes, sir. Good afternoon to all. I am Dr. Praveen Prakash Kulkarni. I am today vote of thanks. Dr. Babasaheb Ambedkar Marathwada विद्यापीठ संभाजीनगर UGC-MMTTC सेंटर यांच्यातर्फे ऑनलाईन रिसर्च रिफ्रेशर कोर्स डिझास्टर मॅनेजमेंटमध्ये जो गेल्या 5 दिवसापासून चालू आहे. आजच्या 5व्या दिवसामध्ये 3रं आणि 4थ्या सत्रामध्ये आपणास डॉक्टर प्रकाश डी राऊत सर, एक्स प्रोफेसर ऑफ अँड हेड डिपार्टमेंट ऑफ एन्व्हायरमेंटल सायन्स, शिवाजी युनिव्हर्सिटी कोल्हापूर यांनी जे मार्गदर्शन केलं त्याबद्दल मी त्यांचे UGC-MMTTC याच्या वतीनं आभार व्यक्त करतो आणि बाकी सर्व जे पार्टिसिपेट आहेत त्यांचे सुद्धा आभार व्यक्त करतो आणि थांबतो. धन्यवाद.
थँक्यू. धन्यवाद.
थँक्यू सर.
थँक्यू.
थँक्यू सर.
एक 2 मिनिटं थांबा.
थँक्यू सर.
इन्स्ट्रक्शन द्यायचे असतील.
ओके. थँक्यू सर. थँक्यू मॅम.